The Earth's axis points at the North Star, and the heavens have been revolving around that star since the dawn of time. Except they haven't. When the Egyptians built the pyramids, the North Star wasn't our current North Star, Polaris. No, it was Thuban. Why did it change? It's because the Earth's axis is moving. This motion was first discovered by Hipparchus. He was looking at the positions of the stars and comparing them with their positions a century earlier at the same time of year. He found that the stars were moving at least 1 degree every century. What could be causing this motion?
When you're riding a car and the car turns, you feel an acceleration.
In the same way that you experience an acceleration when a car turns, there is also an acceleration as the world turns.
This acceleration works against the force of gravity, so you actually weigh less at the equator.
And you weigh more when you're at the North Pole, 1% more.
This also causes the Earth to bulge. The Earth is 26 miles wider at the equator.
Because the Earth is not a perfect sphere, the gravitational force of the Sun isn't perfectly balanced. One side of the Earth gets tugged just a little bit more, and this causes the Earth's axis to spin, completing one revolution every 26,000 years. This also affects the length of the year. Now, you can measure the length of a year several different ways. One way is to look at the seasons. This is called the tropical year. Another way is to look at the positions of the stars. This is called the sidereal year. In January, the sun is in the constellation Capricorn, which means children born in January have Capricorn as their astrological sign. Over the course of a year, the sun moves through all the signs of the zodiac. Once the Earth is back in its original location, we have completed one sidereal year. But the tropical year doesn't depend on the Earth's position. It depends on the Earth's axis. When the North Pole faces away from the sun, we in the Northern Hemisphere experience the winter solstice, the shortest day of the year. If you measure the length of time between two winter solstices, you get a tropical year. So, what's different? Well, if the Earth's axis is moving, it could line up with the sun before the Earth has returned to its original location. This is what happens. Although the effect is small, the axis only moves about 1/100th of a degree, and a tropical year is only 20 minutes shorter than a sidereal year. How did this affect the development of the calendar? Let's go back to the Romans. You may remember Julius Caesar as the man who conquered the Gauls, overthrew the Roman Republic, and named the month of July after himself. But in his free time, he cleaned up the Roman calendar, which was a total mess. Before Caesar, the calendar lasted between 355 days and 378 days. Caesar put it at 365 days, with a leap day every 4 years. This was the Western calendar, until Pope Gregory XIII said, "That's not good enough." He removed some of the leap days to better match the length of a tropical year. The Gregorian calendar wasn't adopted in Russia until 1918, and as a result, the Russians showed up at the 1908 Olympics 12 days late. Why did Pope Gregory base our calendar off the tropical year? What if he had used the sidereal year?
Imagine it's the year 15,000 AD.
And Americans are celebrating Christmas in the middle of summer. And that is what a sidereal calendar would mean. Now, a tropical calendar gets the seasons right, but it puts the Earth on the opposite side of the sun
in the year 15,000.
And so, Geminis will be born in December, Cancers in January, Leos in February, Virgos in March, everything will be backwards.
And as we know from astrology, the position of the sun and planets at the moment you were born predicts all future events in your life. Here's a chart showing you the positions of the planets when I was born. As you can see, I am destined for greatness. Don't believe me? Just look at my horoscope today.
Today, you will make a YouTube video. Some people will think that you love astrology, while others will think you're being sarcastic. But everyone will love your video. For more astronomical videos, please click to subscribe.